Welcome back to We Dared Chemistry. In this lecture, we will spend our brain doing some in-text numerical, so join us whether you are a student or a curious mind. In-text questions, problem 2.8. When electromagnetic radiation of wavelength 300 nanometer falls on the surface of sodium, electrons are emitted with a kinetic energy of 1.68 x 10^5 J mole 1. What is the minimum energy needed to remove an electron from sodium? What is the maximum wavelength that will cause a photoelectron to be emitted? Solution: we have the following given value. Wavelength of the wave is equal to 300 nanometers, so 300 into 10 raised to the power 9 meter. Then we know the kinetic energy, which is equal to 1.68 into 10 raised to the power 9 joules mole. The energy E of a 300 nim photon is given by. But we can also write in this way that energy of a wave is equal to the product of Planck's constant with speed of light upon wavelength of that wave and number of photons. Now substitute the values. Energy of photon is equal to number of photons into speed upon lambda into Planck's constant. Planck's constant is equal to 6x26 into 10 raised to the power 34 joules. Speed of light is equal to 3 into 10 raised to the power 8 meter per second. Energy of photon is equal to 6 milk 26 into 10 raised to the power 34 multiplied by 3 into 10 raised to the power 8 divided by 300 into 10 raised to the power 9. Energy of one photon is equal to 6 mix with 26 into 10 raised to the power 19. So the energy of one photon is 4969 into 10 raised to the power 19 joules, and now energy of 1 mole of photons emitted in the light, 6 mil 626 into 10 raised to the power 19 into 622 into 10 raised to the power 23 mole 1 is equal to 399 into 10 raised to the power 5 joules mole 1. The minimum energy needed to remove 1 mole of electrons from sodium, energy of 1 mole of photon, minus the kinetic energy, 399, 168, 10 raised to the power 5 J mole 1. This is equal to 231 into 10 raised to the power 5 joule mole 1. The minimum energy for one electron, 231 into 10 raised to the power 5 joule mole 1 divided by 6 mu 22 into 10 raised to the power 23 mole 1 is equal to 3084 into 10 raised to the power 19 joule. This corresponds to the wavelength. Lambda is equal to Planck's constant into speed of light divided by energy. 6 small 626 into 10 raised to the power 34 into 3 into 10 raised to the power 8 divided by 3/84 into 10 raised to the power 19. This gives the value of wavelength. Thank you for your attention. Keep studying with We Dared Chemistry.